Chapter is Structure of Atom. In this chapter we will know about the discovery of electron, proton and neutron and their characteristics. Describe Thomson, Rutherford and Bohr atomic models. Understand the important features of the quantum mechanical model of the atom. Understand nature of electromagnetic radiation and Planck's quantum theory. Explain the photoelectric effect and describe features of atomic spectra. State the de Broglie relation and Heisenberg's uncertainty principle. Define atomic orbital in terms of quantum numbers. State Aubau's principle, Pauli exclusion principle and Hohn's rule of maximum multiplicity, and write the electronic configurations of atoms. The existence of atoms have been proposed since the time of early Indian and Greek philosophers about 400 BC, who were of the view that atoms are the fundamental building blocks of matter. According to them, the continued subdivisions of matter would ultimately yield atoms which would not be further divisible. The word atom has been derived from the Greek word atomio, which means uncuttable or non-divisible. These earlier ideas were mere speculations and there was no way to test them experimentally. These ideas remained dormant for a very long time and were revived again by scientists in the 19th century. The atomic theory of matter was first proposed on a firm scientific basis by John Dalton, a British schoolteacher, in 1808. His theory, called Dalton's atomic theory, regarded the atom as the ultimate particle of matter. Dalton's atomic theory was able to explain the law of conservation of mass, law of constant composition, and law of multiple proportions successfully. However, it failed to explain the results of many experiments. For example, it was known that substances like glass or ebonite, when rubbed with silk or fur, get electrically charged. In this unit, we start with the experimental observations made by scientists towards the end of the 19th and beginning of the 20th century. These established that the atoms are made up of some atomic particles, electrons, protons and neutrons, a concept very different from that of Dalton. The topic is discovery of subatomic particles. An insight into the structure of atom was obtained from the experiments on electrical discharge through gases. Before we discuss these results, we need to keep in mind a basic rule regarding the behavior of charged particles, that is, like charges repel each other and unlike charges attract each other. First subtopic is discovery of electron. In 1830, Michael Faraday showed that if electricity is passed through a solution of an electrolyte, chemical reactions occur at the electrodes which resulted in the liberation and deposition of matter at the electrodes. He formulated certain laws which you will study in class 12. These results suggested the particulate nature of electricity. In mid-1850s, many scientists, mainly Faraday, began to study electrical discharge in partially evacuated tubes known as cathode ray discharge tubes. So it is depicted as in the figure. A cathode ray tube is made of glass containing two thin pieces of metal called electrodes sealed in it. The electrical discharge through the gases could be observed only at very low pressures and at very high voltages. The pressure of different gases could be adjusted by evacuation of the glass tubes. When sufficiently high voltage is applied across the electrodes, current starts flowing through a stream of particles moving in the tube from the negative electrode, cathode, to the positive electrode, anode. These were called cathode rays or cathode ray particles. The flow of current from cathode to anode was further checked by making a hole in the anode and coating the tube behind anode with phosphorescent material zinc sulfate. Phosphorescent material zinc sulfide. When these rays after passing through anode strike the zinc sulfide coating, a bright spot is developed on the coating. राइट सो ये एक कैथोड रे डिस्चार्ज ट्यूब है, इसमें वैक्यूम पंप, ये कैथोड है और ये एनोड पार्ट है, हाई वोल्टेज दिया गया है यहाँ पर। राइट, ए कैथोड रे डिस्चार्ज ट्यूब विथ परफोरेटेड एनोड, ये एनोड ये परफोरेटेड कर दिया गया, होल कर दिया गया। The result of these experiments are summarized below. The cathode ray starts from cathode and move towards the anode. These rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials, fluorescent or phosphorescent, which glow when hit by them. Television picture tubes are cathode ray tubes, and television pictures result due to the fluorescence on the television screen coated with certain fluorescent or phosphorescent materials. In the absence of electrical or magnetic field, these rays travel in straight lines. In the presence of electrical or magnetic field, the behavior of cathode rays are similar to that expected from negatively charged particles, suggesting that the cathode rays consist of negatively charged particles called electrons. The characteristics of cathode rays electrons do not depend upon the material of electrodes and the nature of gas present in the cathode ray tubes. तो जो कैथोड की रेस की करैक्टरिस्टिक्स है, मीन्स ना तो वो मटेरियल किस मटेरियल से निकली है उसके ऊपर डिपेंड करती है, और ना ही कौन सी गैस जो बीच में उसमें ट्यूब में रखी गई थी उसके ऊपर भी डिपेंड नहीं करती। Thus we can conclude that electrons are basic constituents of all the atoms. Next topic is charge to mass ratio of electron. In 1897, British physicist J.J. Thomson measured the ratio of electrical charge to the mass of electrons by using cathode ray tube and applying electrical and magnetic field perpendicular to each other as well as to the path of electrons as in this figure. So ये नोड पॉजिटिव चार्ज और ये कैथोड है और ये हमारा इलेक्ट्रिकल फील्ड है और ये मैग्नेटिक फील्ड है, आपस में दोनों परपेंडिकुलर हैं ये। ओके, when only electric field is applied, the electron deviate from their path and hit the cathode ray tube at point A. Similarly, when only magnetic field is applied, electrons strike the cathode ray tube at point C. By carefully balancing the electrical and magnetic field strength, it is possible to bring back the electron to the path which is followed in the absence of electric or magnetic field, and they hit the screen at point B. So ये कह रहा है कि मान लो अगर ये इलेक्ट्रॉन ना होता, अगर ये मैग्नेटिक फील्ड और इलेक्ट्रिक फील्ड, तो ये क्या होता, ये इलेक्ट्रॉन सीधा जाके यहाँ टकराता। कहता है कि जब इलेक्ट्रिकल फील्ड हमने अप्लाई किया तो ये पॉजिटिव चार्ज इलेक्ट्रॉन को अट्रैक्ट करेगा और इधर आ जाएगा। कहता अगर सिर्फ मैग्नेटिक फील्ड होता तो ये इलेक्ट्रॉन इधर आता। अब हमने क्या कि दोनों को इस तरह से बैलेंस किया, दोनों का इतना बैलेंस फोर्स लगाया इक्वल कि ये स्ट्रेट पाथ आके यहाँ स्ट्राइक करे। Thomson argued that the amount of deviation of the particles from the path in the presence of electrical or magnetic field depends upon the magnitude of the negative charge on the particle. Greater the magnitude of charge on the particle, greater is the interaction with the electric or magnetic field, and thus greater is the deflection. The mass of the particle, lighter the particle, greater the deflection. The strength of the electrical and magnetic field, the deflection of electrons from its original path increases with the increase in the voltage across the electrodes or the strength of the magnetic field. By carrying out accurate measurements on the amount of deflections observed by the electrons on the electric field strength or magnetic field strength, Thomson was able to determine the value of E by ME, that is, charge of the electron and mass of the electron, and it comes around this value, where mass of electron is the mass of the m is the mass of electron in kg and E is the magnitude of the charge on the electron, where m is the mass of the electron in kg and E is the magnitude of the charge on the electron in coulomb. Since electrons are negatively charged, the charge on electron is minus E. Next topic is charge on the electron. R.A. Millikan 1868 to 1953 devised a method known as oil drop experiment to determine the charge on the electrons. He found the charge on the electron to be 1.6 in 10 to the minus 19 coulomb. The present accepted value of the electrical charge is minus 1.602176 into 10 to the minus 19 coulomb. The mass of the electron was determined by the combining these results with Thomson value of E by M ratio. So here we are able to find out the mass of the electron as this 9.1094 into 10 to the minus 31 kg. Next topic is discovery of protons and neutrons. Electrical discharge carried out in the modified cathode ray tube led to the discovery of canal rays carrying positive charged particles. The characteristics of these positively charged particles are listed below. Unlike cathode rays, mass of positively charged particles depend upon the nature of gas present in the cathode ray tube. These are simply the positively charged gaseous ions. The charge to mass ratio of the particle depend on the gas from which these originate. Some of the positively charged particles carry a multiple of the fundamental unit of electrical charge. The behavior of these particles in the magnetic or electrical field is opposite to that observed for electron or cathode rays. The smallest and the lightest positive ion was obtained from hydrogen and was called proton. This positively charged particle was characterized in 1919. Later, a need was felt to the presence of electrically neutral particle as one of the constituents of the atom. These particles were discovered by Chadwick by bombarding a thin sheet of beryllium by alpha particles. When electrically neutral particles having a mass slightly greater than that of protons were emitted, he named these particles as neutrons. The important properties of all these fundamental properties particles, we can see it in the table also. So here it is the Millikan oil drop method. In this method, oil droplets in the form of mist produced by the atomizer were allowed to enter through a tiny hole in the upper plate of the electrical condenser. The downward motion of these droplets was viewed through a telescope equipped with a micrometer by eyepiece. Measuring the rate of fall of these droplets, Millikan was able to measure the mass of oil droplets. The air inside the chamber was ionized by passing a beam of X-rays through it. The electrical charge on these oil droplets was acquired by collision with gaseous ions. The fall of these charged oil droplets can be retarded, accelerated, or made stationary depending upon the charge on the droplets and the polarity and the strength of the voltage applied to the plate. By carefully measuring the effects of electrical field strength on the motion of oil droplets, Millikan concluded that the magnitude of electrical charge Q on the droplets is always multiple of the electrical charge E, that is Q is equal to N, where N is equal to 1 to 3. So that is integral multiple electrical charge, that is Q is equal to Ne, that is the quantization of the charge. तो ये ऑयल ड्रॉप एटोमाइज़र से ये ऑयल ड्रॉपलेट्स आए, चार्ज पार्टिकल एक्स रेज फ्रॉम द सोर्स, उससे ये चार्ज किए गए, टेलीस्कोप से व्यू करते हैं ये चार्ज पार्टिकल, ये सो these gets charged, right? So these are the oil droplet under observation. सो क्या किया इसमें, जैसे ये डाउनवर्ड मूव करेंगे अकॉर्डिंग टू द मास, और ये इलेक्ट्रिकल फील्ड से जो है इसको बैलेंसिंग रहेंगे, तो वो ये जो दोनों फोर्सेस बैलेंस करेंगी, तो उससे हम ये फाइंड आउट करेंगे. द मिलिकन ऑयल ड्रॉप ऑपरेटर्स फॉर मेयरिंग चैम्बर चार्ज E. So in chamber the forces acting on the oil drop are gravitational, electrostatic due to electrical field, and viscous drag force when the oil drop is moving. तो viscous drag ये अपर जाएगा, ये ऑयल ड्रॉप नीचे आ रहा है तो viscous drag इसको अपवर्ड करेगा, ग्रेविटी नीचे एक्ट करेगी, और इलेक्ट्रोस्टैटिक जो है ये अपवर्ड एक्ट करेगा.